we're going to go ahead and assign oxidation numbers to every single element on both sides. Okay, so let's review the rules. An atom by itself that does not have a charge indicated is 0. It has the same number of protons as electrons, so it'd be what it naturally occurs like on the periodic table. So any element by itself is 0. Okay, now if we have elements combined, we need to use rules. These rules are, if we've got ions that have metals, so if we have metal ions, then the charges indicated on the periodic table is the oxidation state. So we've used that rule in the past in which to put together compounds. All right? Fluorine's always a -1. It trumps everything. We tried to talk a little bit about pitch. Aces trump everything. So fluorine trumps everything. It's always a -1 no matter what it comes in contact with. What's the next one that trumps everything but fluorine? Oxygen's always a -2. Okay? Now if it's put with fluorine, it becomes a positive oxidation state. Because fluorine outrules oxygen and it takes on the electrons. So then the next one on the list I think is chlorine. Chlorine will always be negative unless it's with oxygen or fluorine and so on and so forth. And we look at electronegativity. So if you guys were gone to K-State, we said if we look at the electronegativities and we have one that's a higher electronegativity than another, then that one always takes on the charge of its monoatomic anion. It always takes on that negative charge, and the other one's positive. We'll see some examples here, like this one, CO2. We look at CO2. Oxygen, it's not bonded with fluorine, so it would be a -2. So then that's a -4, so carbon's going to be a +4. Oxygen has an electronegativity of 3.44. Carbon is like 2.2. So pretty much carbon's going to be a positive all the time because it has a low electronegativity. Okay? Unless it's bonded, I think, to hydrogen, and then at that point, that changes. Questions you guys have? So let's take this first one for example. So I think we've covered all the rules. Hydrogen is always going to be a positive when it's bonded to other nonmetals. So hydrogen is always positive when it's bonded to other nonmetals. When it's bonded to a metal, it takes on a negative charge. So potassium's oxidation state on this first one's what? 0. Now we look at hydrogen and oxygen here, and we have to assign for both hydrogen and oxygen. So what would be oxygen? -2. So hydrogen's +1. And I'm just giving the overall charge. I'm not saying hydrogen's a +2. So when I assign the oxidation numbers above, I'm giving exactly what each individual atom oxidation state would be. So over here we have KOH. Which one do you want to give an oxidation number to? So which of those do you know for sure?
K.
K, what's that?
+1.
+1.
-1.
-2.
Oh, it's not like OH.
Well, it is OH, but O is a -2. Remember, oxygen's always a -2 unless it's with fluorine or it's a peroxide, and we'll get to peroxides here in a second. So pretty much 90-something% of the time, oxygen's a -2. So hydrogen's bonded to oxygen, which means it's covalent. So hydrogen's what? +1. It all equals 0, right? When you add everything up. So this hydrogen, even though it's diatomic, it's still by itself. It's bonded to itself. It doesn't really matter. It's still by itself, so it's 0. Does that make sense? So anything that's got a subscript, but you still only have one of them, it's 0. Okay. So let's look at what creates what we call a redox reaction. This is called a redox reaction. And a redox reaction has reduction taking place and oxidation taking place. So what is reduction? Reduction is when an atom lowers its charge. Oxidation is when an atom will become a higher charge or a more positive charge. Okay? That's one way of looking at oxidation reduction. The actual terms associated with reduction, reduction is gaining electrons, and oxidation is losing electrons. So here, let me give you an acronym that represents the two. And that acronym is oil rig. Have you ever heard of oil rig?
Yeah. Yep.
Now, I think last year we talked about oil rig, but 2 years ago, I don't know if we did much with oxidation reduction. I don't think we did. But I think last year we went over oxidation reduction. So, O stands for what? Oxidation is losing. Losing what? Electrons. Okay? Reduction is gaining electrons. Now, here's the problem that I have a lot of beginning chemistry students, and some of you kind of forget from time to time. If it's gaining, sometimes students think this is gaining. So I'll have students say, they will say that is gaining electrons. So they say that's reducing. That's not reducing. Okay? Because reduction is gaining electrons. What has happened to this? It lost 2 electrons. So this is becoming what? Oxidized.
So it's sort of like hydration and dehydration reactions?
In what aspect? I'm not sure when you say hydration.
It loses the same, like dehydration you're adding water, and hydration you're losing water.
But it also depends upon your reference point.
Yeah.
I know what you're talking
Yeah.
about. Because when you become hydrated, you're gaining water, right? If I say go get hydrated, what are you going to go do?
Get water.
Drink water. So it's the reference. In what reference are you talking about?
Glucose molecules
Okay.
for body, in the body.
Right. So it's your reference point.
Yeah.
And so we won't get into that, but if we were doing this here, so it's going from, this is 0 to +2, this is going from 0 to a what? -1. Each one of those is a -1. Okay, 2 chlorine ions. So what's chlorine done? It's gained electrons, so it's being reduced. Copper is being oxidized, and so it's becoming a higher charge. So everything we do with electrochemistry, when we get into doing electrochemistry and all of what that is toward the end of the year, and oxidation reduction reactions have to go with this idea. That if you're reducing something, you're picking up electrons. If you're oxidizing something, you're losing electrons. Okay, enough said on that. So oil rig, if you forget. Oxidation is losing electrons, reduction is gaining electrons. So on this example, what's being oxidized on the left side? So this is going from 0 to what? +1. So potassium is being what? Oxidized, right? Any questions with that? How many electrons is being lost? For each potassium that goes from the left side to the right side, how many electrons are lost? 1. So you guys don't have to do this, show this, but I'm just going to go ahead and show it. So it loses 1 electron. Now, some of these equations can get really, really tough to balance, and we're not going to go there. We can have some redox reactions that are impossible for you guys to balance. You would be spending all day trying to balance it. And it is something that can balance, but it's really, really tough. And you almost have to use a method, and I'm not going to go through the method. You don't have to ever do it. Where you can show electrons lost and gained are equal, and then you can figure out the balance equation. And we're not going to go there and do that, because I'm kind of running out of time a little bit. So, if something's oxidized, you have to have something else reduced, because electrons have to go somewhere. So if potassium's losing electrons, something has to be picking them up. So what's picking it up? Hydrogen. See this hydrogen here? That hydrogen goes from here to the H over here, isn't doing anything, but the hydrogen that's going from here to the H2 would be said to be gaining what? 1 electron for every hydrogen that goes over there. So hydrogen is gaining. So we would say that H2O is reduced. So we'd say the H plus 1 ions being reduced. Any questions with that? Make sense? All right, why don't you guys try to do the next one and see if you assign all the oxidation numbers correctly. So go ahead and assign all the oxidation numbers for that one and see if you assign them correctly. I kind of like doing these. Personally, I kind of like. So that would be a case when you take a look at the electrons gained and lost, kind of how they would be going. If you notice, oxygen is going to 2 places. In both places, they're -2. So.
Wouldn't hydrogen be oxidized too?
Nope, it's a +1 here, and it's a +1 on that side.
Oh.
So they're +1s on both sides. So if they're the same on both sides, nothing happens to them. All right, let's go ahead and do the third one. Carbonate's a -2. I'm going to go ahead and give you the charge for the whole thing. So carbonate is a -2. So you don't have to look that one up. +2, right?
Yes.
And oxygen's a -2, right? So this carbon is a +4. Copper over here is a +2. Oxygen's a -2. Carbon +4. Oxygen a -2. Right, so this is not a redox reaction. This is just called a decomposition reaction and nothing changes. So there's no exchange of electrons. Yes?
How did you get +4?
For carbon?
Yeah.
So this all over thing equals a minus 2. So if we got CO3, and that whole thing equals a minus 2, then oxygen is always a negative 2, and that means it's a minus 6 total.
So wouldn't it be positive 8?
If it's positive, that'd give you plus value.
Oh.
Or, I mean, it would give you...
I thought like
Okay.
negative 8, but then that
Yep.
would be negative 14, so that's my bad.
Yep. So that would be...
Sorry.
No, that's okay. Alright, so that give you, yeah, plus 4. So this would not be a redox reaction. Okay. So what I'm going to have you do is I'm going to have you guys practice this on your own. Okay, let's do let's just do this one here real quick, and then they'll do one more. And I think you'll have good enough examples for this.
Do both, or just the top one?
Just do the top one, and then I'm gonna show you one that would be impossible to balance. Be almost impossible to balance unless we do it a different, but approach balancing in a different way. But I'll never give it any of these on the test for you to do. They're just kind of neat to take a look at once. A lot of these ones that are more complex, they take place in acidic and basic solutions. And your text kind of gets into that a little bit, but we're not going to go. We're not required on an AP test to know that kind of stuff, so that's why we don't really go through it. So this first one is 0, plus 1, minus 1, plus 3, minus 1, 0, right? Is that what you got? So aluminum's oxidized, right? And then hydrogen's reduced. Got it? Okay. So this last one, if you want to write it down, you can.
Is this the impossible?
Yeah. Well, near impossible. If you just do it by sight. You say, hey, I'm going to do this by sight and balance it by sight. It's kind of like me doing Sudoku. I can't do it. So.
I'm terrible at it.
At least the real tough ones. It's like I give up. Alright, so this one's going to have some bigger numbers associated with it. So this will be a good practice for you guys to assign oxidation states. So go ahead and assign oxidation states for every element like you did on the other two examples.